Hello, it's Professor Zawala again. With another video focusing on the mathematics section of the West African examination, Council Senior Secondary School examination for Liberian schools. Today we're going to be going over a large subgroup of number enumerations and a subset of sequences and series. It's actually F sequences and series, and we're going to be determining any terms of a sequence. So before we can do that, let's define what a sequence is. A sequence of functions whose domain is a set of positive integers. So the domain would be like 1, 2, 3, 4, 5, 6, 7, 8, and on and on. And the number of the range is what we call the terms of the sequence. Now, there are two basic types of sequences, and we will talk about. One of them would be like arithmetic sequence, and in an arithmetic sequence, as you know already, there is what we call a constant difference, which we call the common difference. That is, when you subtract two successive terms, you always get the same value. And when you have an arithmetic sequence, the terms of an arithmetic sequence can be determined by using this formula. In this formula, n is the number of the term, the n term. A1 is the first term, n is that term, number of terms we're going to find, and then d is the common difference. Okay? Another sequence, as we said, will be the geometric sequence, which you know about already. And you can determine that by two basic formulas. One formula, an. You do A1 times R, which is a common ratio. For a geometric sequence, we have a common ratio. That means if you divide successive terms, you have the same value. And you can use one of these two formulas to find that. Also, then we have a series. So basically, a series is the sum of the terms of a sequence. And one of the ways we can do it is by using summation notation. This is called sigma. What it does is that it indicates that you are adding starting when k is 1, going all the way to when k is n. Alright, and then we can also have some formulas for finding the sum of a series. Say if you want to find the sum of the first 5 terms of arithmetic sequence, you can use this formula over here. N is the number of terms, A1 is the first term, D is the common difference, and N is the number of the term that you want to find. Then we can, when it comes to geometric series, there are two cases. One, whether the series is finite. If the series is finite, then you can use this formula over here. And the second one, you have an infinite series that continues on and on. Now, for that, it's a condition that R must be less than 1, otherwise you say it diverges. Okay. So let's do problem number 1. Problem number 1 is taken from the WAEC exam, which was administered in 2011. That was problem number 6 on that. So it gives us here 2 to the power 2n, and it wants us to find the third term of this thing. So, well, that means our n here is equal to 3. So the first thing we need to do here is to substitute the value of n into this problem. So we must replace n with 3. And then we use the laws, or we use the rules for dealing with indices. So we're going to write 2 raised to the power of 2 times n, which is 3, all times. Now, the first thing I'm going to do here, and there's a negative right here. The first thing I'm going to do, I'm going to put a negative here, and then I'll do 2 to the negative 1 instead of keeping it down there. And then I'll put the n here, which is 3. So basically what I have here will be 2 to the 6 times negative 2 to the negative what? 3. Well, 2, 2, I can take out the negative up there and have 2 to the 6 times 2 to the negative 3. They have the same base. And so then I can do 2, keep the negative out, and do 2. So it's going to be what? 6 plus negative 3 and that will be negative. Then I will have 2 to the positive what? 3, and 2 to that will give me what? 8, and my answer will be negative 8. Okay, so that's how we do it. Basically, we just apply the laws of indices over here to do it. You could do this even another way by bringing that down, keeping it down, stay and stay, get the same answer. It's 27, and the last term is 188, and it has a common difference of 7, which wants us to find the number of terms. So, few things. It's an arithmetic progression. We must use the formula for finding the term of an arithmetic progression. So let's go ahead and see how we do it. So let's take some information. So based on this problem, our A1, the first term here is 27. And the last term, our AN, is since they said the common AN is going to be, we don't know what the number that is, but AN last term is 188. It has a common difference of what? 7. Good. So let's write the formula for this. So the formula for finding the term of an arithmetic progression is given by AN is equal to A1 plus N minus 1 times D. Now we know that AN here is 188. We know that A1 is 27. Plus, we don't know what N is. That's what we are finding. So we keep it as N minus 1. But we know that D is what? 7. So let's subtract here first. We're going to subtract 27 from both ends. So what do we have then? We have 161 equals to 7 times N minus 1. We're going to divide it by 7, divide by 7, and I want to move right over here. We'll do that division. We're going to have 23 equals to N minus 1 because the 7 will cancel here. So what we have now is basically to add 1. So we're going to have 24 equals to N, so which means N is equal to 24. That means this progression has 24 terms. Now, one of the first things you need to determine here, first of all, whether this sequence is or progression, as you prefer, as it is called, is arithmetic or geometric or neither. So when I'm looking at it to see whether it's arithmetic, I'm seeing that if I do 12 minus 4, I'm going to get 8. If I do 36 minus 12, I'm not going to get 8. So it's not arithmetic. But now, if I divide 12 by 4, I'm going to get 3. If I divide 36 by 12, I'm going to get 3. If I divide 108 by 36, I'm going to get 3. So this is a geometric sequence. So I'm going to use the rules for a geometric sequence to be able to find what I need. So the first thing, to find my R, this is what I did. I did AN divided by AN minus 1, and I will show it to you. For example, if this is my AN 12, AN minus 1 means the term before that, that will be 4. If I'm looking at this as my AN minus 1 is this before that, that will be 12. And 108, and the one before will be 36. You can see that if I do any one of these divisions here, I'm going to get 3. So my common ratio here is 3. N for me is going to be 7. My first term here, A1, is going to be 4. And I'm trying to find the 7th term of this. So I'll do A7. And by rule, the formula is equal to A. Let me just write a general rule for AN is equal to A1 times R to the N minus 1. Now let's substitute. A7 equals to A1. A1 is 4. The common ratio here is what? 3. My N is 7. 7 minus 1. So I'll have 4 times what? 3 to the power of 6, and if I do this calculation here, I'm going to get 2916. So the 7th term will be 2916. Basically, this ends our section on finding the term of a sequence. Very basic, very easy, very simple. Get some practice. Visit our website at www.freeliberia.org. familiarize yourself with some of the problems that have been, that will come on, that generally come on the WAEC. Again, thank you very much. This has been a production of you. We are committed to providing more and more of these kind of videos and expanding our services to other content areas. Your contribution, your support will be very much appreciated, and it will help to make our work easy. So, like us on Facebook, follow us on Twitter, subscribe to our YouTube channel, and please, if you can, make a little contribution to this cause. Thank you very much.